Swayam Prabha. Digital India. Educated India.
Okay, students, so today we will start again the tuning method that can be applicable for other electrodes also, right? I told you the tuning method for like gold electrode, gold disc electrode. Let's try some other electrode, other materials also. So this kind of tuning should be applicable for other material. Let's see this pre-treatment method, is it applicable for all or not? So let's investigate this all the phenomena so that you will get a general concept for this tuning method. Then we will go back again the sensing development. So mainly I will cover today the different tuning method of gold and platinum electrodes. Then we will discuss then again this dependence of the activities on the pre-treatment on this gold and platinum, and then their aging effect. See, main keyword, that's why today's topic is the gold and platinum electrodes and their aging effect. See here the schematic. So I wanted to show you a basic concept of the different treatment. Especially I am saying here the pre-treatment. One is the piranha, another is mechanical polishing, and last one is sodium borohydride treatment. Okay, so let's show you. Piranha treatment, it is the solution that contain sulfuric acid and 38% of the hydrogen peroxide, and this mixture is a 3:1 ratio, and we will heat this solution for 80 degrees Celsius for 10 minutes, and then we will dip the electrodes, suppose for the gold electrode for 10 minutes, and we will see the surface screening effect, their electrocatalytic effect. So I think you slowly understand that how we can go for the different pre-treatment procedures, and let's use them for sensing applications. So still fundamental all the pre-treatment method I am teaching you. See, the when you will go for the piranha, right? So for first example is the piranha. So last class I didn't cover much the piranha, that's why today I will cover mainly the piranha treatment. So what you will do, so just in a beaker, so you have to take 38% of hydrogen peroxide and concentrated sulfuric acid. Concentrated sulfuric acid and hydrogen peroxide. So sulfuric acid is 3 and hydrogen peroxide is 1. Okay, and then you have to heat it in the 80 degrees Celsius, and this solution there you can dip your small gold chip electrode, and then maybe you can wait for 10 minutes and then wash it in the DI water. You have to wash, then check their electrocatalytic activity. Today I will show you their all the surface phenomena, means after piranha treatment you can see the surface roughness how changing. Also I will compare this piranha treatment with other treatment that I already taught you. One is the mechanical polishing, and is the sodium borohydride treatment. See, mechanical polishing case, generally we already have seen that surface roughness change, right, Hill and Valley type, and after the polishing, before the polishing you can see. And sodium borohydride treatment, you already have seen the surface roughness, that's called the RMS value, root mean square value, RMS. You can see here the RMS 2.5, 3.6, 1.3. So it's telling about the surface roughness. Especially in the sodium borohydride case, if you compare, so this is the just before the treatment. Before the treatment, RMS value 1.2 nanometer, and after the treatment it is almost similar. See, just for the sodium borohydride case, this is the AFM, atomic force micrograph, this image. See, in this case the roughness is almost similar. 1.2, 1.3 means we are saying almost similar, there is no change. But you can see here the 1.2 nanometer the before treatment, but mechanical polishing case this roughness change 3.6 nanometer, and the piranha case it's changed around 2.5 nanometer, and it becomes little rough surface. So then how it will affect on the electrocatalytic activity? As I told you, you wanted to check, mainly if you want to check the electrocatalytic activity after different pre-treatment, let's choose some substrate. So for example, I told you can choose substrate like the glucose, or you can choose hydrogen peroxide or formic acid, or maybe hydroquinone that will convert to benzoquinone. So this one is almost, you can see the reversible peak. You can remember the cyclic voltammetry, you can see the almost reversible peak for the hydroquinone, like hydroquinone will oxidize to benzoquinone. This is the oxidation, and then benzoquinone will reduce to, this is the reduction to hydroquinone again. But this kind of substrate case we will see it is the irreversible phenomenon. The glucose case or formic acid case or hydrogen peroxide case, they will show like this, then it will reduce. So that's why generally when I will show you the electrocatalytic activity change, let's check there only the oxidation peak. No need to check the reduction peak. So you can see the glucose oxidation like this, then we are not taking the reduction peak. You can consider like this way. That's why we check the glucose oxidations for piranha treatment case, and then check their aging effect. Means after the treatment you can store just in the room temperature without, generally you are storing your sensor surface in the lab like this way, not the very special treatment, special conditions you are storing. Let's see their aging effect and how their electrocatalytic activity actually changing. The interesting thing you can see, so we will check here 1, 2, 3 sodium borohydride, and you can see here 2 treatment, 1 is 2 is mechanical and 4 also mechanical. So in this all the electrode here we are using here gold plate electrode for first 3, 1, 2, 3, they are the gold plate electrode. And this one mechanical polishing, with this one we choose as a gold disc electrode. Okay. So why we can say that's why you change this kind of like the plate to disc, because when you develop some chip, mainly we are coating the electrode with some gold, right? We are not using the pure gold. So that's why we wanted to see all the treatment effect on the coated gold and just pure gold. So in the first 3 cases, in the coated gold, you can see the piranha treatment case. Just after treatment, you can see generally we are getting huge electrocatalytic activity. But if you compare the others, see it is around 400 microamps. But in the other case, like mechanical polishing case, is too low and is this much. See, and for the sodium borohydride treatment case, it is up to here. It is around 100 like 80. And for the disc electrode case, but definitely the disc electrode and the plate electrode, their surface area different, but that's why you cannot compare this and this. But 1, 2, 3, they all the 3 cases the surface area same. So why I am saying the surface area A? Because the current is directly proportional to your electrode surface area. See, if you have the higher surface area, definitely, because you will get the more active surface for oxidations of your substrate like glucose, hydrogen peroxide, formic acid, definitely will get the higher current. So this 1, 2, 3 case, actually still you can see piranha case you are getting the higher current, all those surface area same. This is because piranha can enhance the activity much better than other treatment. Now let us compare their deactivations. One important phenomena we can observe here, that the treatment which help to activate the surface is too high. In that case, deactivation is also slowly it will deactivate. See, after 1 day, 3 days, 7 days, it's changed very slowly. Why it's changing? Because we are not taking much precautions about the storage condition. We are simply storing in the lab environment. So there may be some change, but that all the causes, again I will show you all the factors, the contamination factor, there is a reconstitution effect or not, that also I will show you, all the XPS study, AFM study. So from here, that's why the interesting phenomena is that if your surface is activated, highly activated, in that case deactivation is also little slow. See, the mechanical treatment case is see these surface area same, but you are seeing that just not that much activated, and deactivation also rapid. It means the surface was not cleaned properly, and it is actually affecting on your surface deactivations too. So this is very interesting phenomenon, right? These two observations. Again, you can compare with another third conditions, that is sodium borohydride treatment. See, just after sodium borohydride treatment, we can see the glucose oxidation peak around 180. So it is medium, like this one very highest, then second you can say this one second, and this one third, if you compare the activation rate. See, sodium borohydride case also, it also deactivated, but also not that much rapid like the mechanical. Means the mechanical polishings, after the mechanical polishing you may need something else also, cleaning. That's why last class also I taught you, after the mechanical polishing you can go second step, that is electrochemical polishing. Again, electrochemical polishing. What is that electrochemical polishing? Let's I can remind you one more time. So let's remove this part. So I'm going to remind you all the polishing steps. That's why you should follow just after mechanical polishing, because as you know, from this behavior it is confirmed that mechanical polishing is not enough to clean the surface, right? So first you follow number 1, mechanical polishing. So it is done. So after mechanical polishing, as you can remember, you have to keep your electrodes in the DI water. Then you have to sonicate it. Sonicate it for 15 minutes. Then you can wash again the surface. Then second you can go take this is the electrochemical cell. One electrochemical cell, you can dip your working electrode, your reference electrode, and your counter electrode. Then you can connect this setup with the potentiostat, and you can cycle around like minus 0.2 to 1.4 volt, and for around 20 times or around 20 times you can potentially cycle. Oxidation, reduction, oxidation, reductions. Then your surface will be clean better than mechanical polishing. So sodium borohydride case, you know already, it is very simple cleaning, but still it will not activate completely if you compare with the piranha treatment. Okay, but for the mechanical polishing, you can see again. So where we use just a disc electrode. You can remember last class I taught you. You should have a pad, polishing pad. Here you have to put your all the aluminum slurry, then polish it like number 8. Like this way, you have to polish like this way for around like 1 minute or 2 minutes. You can polish it, and then go through again all the cleaning method, and you can check just after polishing. Then after storage in the room temperature in the laboratory environment, you can see the deactivation. See, in this case deactivation also too fast, it's very fast. So that's why this mechanical polishing, pre-treatment and then storage for the longer time is not recommended. So you have to take care of this electrocatalytic activity, otherwise you may not get the reproducible data if you store it for the longer time. It's very important information. That's why aging you have to keep in mind. while you are developing the sensor. So why I am teaching nowadays this all the pre-treatment method I'm using, because to get the reproducible surface so that you can develop a reliable biosensor. Clear? Let's show you the probable reason again. I think last class also I told you the surface contamination. Today again I will show you all the study has done for the gold electrode, but in this case gold plate electrode. We want to compare like disc electrode and plate electrode also. Plate means just you can take a like a glass substrate, then you can coat with thermal evaporations, maybe some coating you can use the gold, so pure gold you can coat. So on that case we can see the surface contamination. Now I will show you the another things is the surface reorganizations, or this is called surface reconstructions. So today I am going to show you the actual structure of the surface reconstructions. You can see maybe surface the atom they are organizing themselves after the pre-treatment, surface atom after polishing, after sodium borate treatment, after mechanical treatment or after pinana treatment. So what happened? The surface atoms they are reorganizing themselves. So if you wanted to study more details, so you can go this reference, progression surface reference. So this is a full elaboration is there. So you can go through this book also. But just try to understand the basic things, the surface reorganization, surface reconstructions that help to generate some metastable stage. That metastable state during the treatment or during the synthesis, I don't know, when you will synthesize some nanomaterial, so nanoparticle during the synthesis or just after synthesis, if you measure the electrocatalytic activity, it will be very high, right? Then this activity is slowly changing. So this is also because of some metastable stage is forming. So this is because of some surface reconstruction. So this is the actual explanations of the surface reconstructions, or this is just the hypothesis, but let's study some surface characterizations to understand if there is anything else happen, surface contaminations, or there is any material on the surface or not before and after treatment. Just I am trying here all the plate electrode, plate, this is gold plate electrodes. Okay, if you see all the gold plate electrode just after this 3 pre-treatment. So here we studied photoelectron spectroscopy, XPS, X-ray photoelectron spectroscopy. You see we generally are getting the gold peak in this region, 2 peak we are getting 84 around the 88. So these 2 region we are getting gold peak and carbon peak around this region. You see just after the pinana treatment. Why I mentioned here after 2 hours, because when you are doing some pinana treatment in the lab, then you are cleaning, then you have to go to the XPS chamber to XPS room to study these things. So it may take some time. That's why immediately it was difficult to take the XPS. So we wanted to see the exact aging effect is there or not. So actually we take after treatment after 2 hours we took this data. You can see there is not here not that much change, but little bit change still there after 7 days. Means you can see just after and after 7 days, but little bit you can see still gold peak decrease, right? It means gold peak is covered maybe some contaminations may possible, because pinana treatment is very strong cleaning method. It can clean almost all the organic contaminant from the surface, and when you store for the longer time like 7 days in the laboratory environment, see somewhat this gold peak actually covered. So we thought maybe this is due to not only the surface reconstruction, also some contaminations may come, right? That contaminations means generally the organic contaminations where we are thinking. So we check the carbon contaminations. You see here the carbon contaminations peak just this after 7 days. See gold case peak decrease, but carbon case peak increase. Why? Because gold can be covered with some carbon contaminant, so gold peak should be decreased, and carbon peak after 7 days should increase. Why? Because carbon amount is increasing. So, you can see this much amount means increasing actually. So, little bit contaminations there, that we can tell from this X-ray study. Now, check the mechanical polishing case. You see, mechanical polishing case is not that much change we can see, because as I told you, if you go back the peak here, it is not that much actually increase also the activity. So, anyway, maybe the surface is not fully clean, that we can say, right, just after mechanical polishing. That is why you can see that if you compare the intensity and the change after 7 days, it is not that much. But piranha case, we can see the clear change. Why? Because piranha can almost clean the surface. That is why if little bit change of the carbon contamination there, we can see the change in the X-ray study. But sodium borohydride treatment case, we can see the gold's peak, see almost no change, carbon peak almost no change. So, let us go back the sodium borohydride treatment case. So, in this case, we can see the enhancement here, but this enhancement not due to the cleaning of the contaminant. This is maybe due to the surface reconstruction. That is why I am saying they are not only the reason of the carbon removal contaminations for this activation change, but also the surface reconstructions or surface reorganizations, mean this factor. That is why we assume this factor. That sodium borohydride case, that we can say, although the surface is not that much clean by the sodium borohydride treatment, but still why we can see the enhancement. This is because when sodium borohydride treatment we are carrying out in a solution, so you know the Na plus and BH4 minus is forming, and I think I taught you already from this borohydride, this hydrogen atom can adsorb on the surface, and this hydrogen atom can actually make some metastable stage, some strained surface. Due to this, maybe this activations, this electrocatalytic activations we can improve. So, from this sodium borohydride treatment, you can say, see the gold surface is not much, you can see peak almost not much change after treatment after 7 days, but still we can see the activity change. Carbon also not that much change after 7 days also. Now, let us see the other peak region. This is the complete study of the XPS. Means if you want to study the contamination factor, you have to study this all the region on a main transducer surface or electrode surface. So, first you have to check the main metal, that area, then carbon area, that you have to check. Then you can also have to check nitrogen and oxygen part, because your organic material may contain some nitrogen and oxygens also. So, this region also you may see some change or not. You can see nitrogen oxygen is not that much change. So, mainly because of some but very little change maybe you may see, but not that much predominant. So, contamination is there, but maybe little bit, not too much. Now, in this scheme I am going to show you how this treatment can affect some other material. So, up to now here I told you all the studied for the all the things have been studied on gold electrode, right. Now, let us see this all the investigations on another electrode or on another material, so that you can check that this kind of pre-treatment or this kind of deactivation procedures that I am teaching you is the universal things, or just for very much depend on the very specific material, right, that you have to understand. So, here that is why I am going to show you something, this kind of pre-treatment method on platinum. Let us see how platinum effect, means platinum electrocatalytic activity is changing. Here I just showed you like this way. This is just a platinum disc electrode informations I am going to show you. So, I think you already understood the disc electrode means something it, it is commercially available, it is shaped like this. Here almost the pure platinum we are using. See, and we measure here oxygen reduction. So, you may ask why not you change the glucose oxidations? Yeah, it's fine. That also you can check glucose oxidations or formic acid, hydrogen peroxide, other things. But platinum actually very much active for the oxygen reductions. That's why we focus on oxygen reductions. Means, see, we wanted to see the aging effect. Maybe after one day or after few days, there is a very small change due to the aging effect. So, how you can measure? That also depend on how your surface means your like in this case the platinum, how this surface behave during this catalytic measurement. Like if you measure like oxidations, like you can measure glucose oxidations, but this oxidation change, peak change, oxidation current change during the time interval may not be that much. But here why I choose the oxygen reduction for the platinum case? Because oxygen reduction is very much dependent on the material on your transducer surface, and platinum is showing very catalytic activity on oxygen reductions. So, we choose here oxygen reduction, that is why. So, here also I will show you like sodium borohydride treatment on the platinum, and here you can see how rapid this oxygen reduction reaction change during the measurement. See, reduction, you can see here one diagram. This is the oxygen reduction. See, we are measuring here from right to left. We are measuring from means we are measuring reduction current, and this is just the aqueous solutions. Here we are not using any kind of substrate, just aqueous solution. When for the measurement of the oxygen reduction reaction of platinum, we are using perchlorate solutions. So, around 0.1 molar perchlorate solution. So, it is little acidic, it is acidic solution, and we will scan your cyclic voltammogram from right to left. So, see 0.8 to minus 0.2. You can see this red one, this one just after sodium borohydride treatment, and then this blue one, this is after aging effect, maybe after 1 week. You can see this deactivation means as it is shifted towards left, you can see this oxygen reductions, you can see the highest here, but in this case see this actually shifted towards left after the aging. So, in this case we can say that this electrode actually deactivated after the aging. I think I can show you again, like if the oxidation speed shifted towards the right, then we can say that surface are deactivating, and if reduction speed shifted towards left, then we can say surface actually becoming deactivated slowly. So, you can see the reduction speed for the oxygen case, it is shifted for after the aging. So, we can say the surface actually deactivating. So, that phenomenon actually I will discuss you more details in the next class. That also I will check this one for platinum nanomaterial also, that also I will discuss also in the next class again, and how during the aging factors actually affect during the long time storage in the laboratory environment for the platinum nanoparticle also, that also I will discuss in the next class again. That's all for today's class. Thank you all.